Hello, everyone. Thank you for attending this webinar. Today, I'm going to introduce how to use VTK to develop 3D and visualization applications. Before we begin our VTK journey, let's look at the typical way of doing 3D graphics with OpenGL, an industrial standard graphics library. So here is an example of displaying a box. So we need to draw the 6 faces one by one, each of which is specified by its 4 vertices. And for other primitive shapes like a cone or cylinder and spheres, and you need first to approximate the curved surface with planar polygons. So you can get a lot of polygons depending on the resolution you want to have. So the question is, are there other libraries allow us to specify objects like this with just a few parameters like height, radius, or resolution, instead of going to the level of vertices like OpenGL? So VTK is such a high-level visualization library. And today, I'm going to get you up the learning curve faster. So we don't require audience have a strong programming background, but if they do have some kind of programming experience, that will help. So so this tutorial will intermix with the introduction with examples. So we will later on we will go through quite a few examples. So I organized the talk in this way. So we will begin with an overview of VTK, followed by some basic concepts. And then I will present a hello world type of application, very simple, but it shows most of the basic components that you need to construct a VTK application. And after that, we will take a closer look at the architecture of VTK and some of the major classes. Once that is done, it's time for us to take a look of some more sophisticated applications. But in terms of physics, just give us a more powerful display, and the code should be very simple. And after that, I will go through some major advanced topics. But for most audience, my hope is that you understand the basic part and you can start your exploration by yourself. For the advanced topics, if you are really interested, because due to the limited time, I can only mention them, give you a ballpark figure, but you need to explore by yourself. And after that, I will conclude the talk by providing the resources that you need later on for your own exploration. And I will reserve about 5 or 10 minutes at the end of this talk for questions. So let's take a quick look of VTK. VTK right now is 21 years old. It's open source, maintained by Kitware, and it's a high-level visualization library and providing powerful 3D graphics, image processing, and visualization functionalities. It can be built on multiple platforms. It is written in C++. But it provides typical Java and Python wrappers. That means you can program with those three script languages. And in general, when you program with VTK, your code should be very short, much shorter than otherwise you're programming in OpenGL. In terms of achieving the same functionality. And VTK has many users and many code contributors, and it keeps growing, and it's very active. It has been used for visualizing very large data in parallel by, like Sandia National Lab, Los Alamos National Lab, and U.S. Army Research Lab, etc. And it's quite successful library, and it's well documented, and it has a wiki page, and also it has a mailing list. So for new user, you can certainly get a lot of help, or when you started your exploration of this new powerful tool. Okay, so to learn VTK, you need to understand the two distinct concepts. One is data. The other is module that process those data. So VTK support many different types of data like structured, unstructured, like regular grid or curvilinear or unstructured data. So those data classes are all subclasses of a VTK data object. And the other one, like I said, is a module that process or transform data. It's called a VTK algorithm. So there's many subclasses from VTK algorithm. And those module or classes can either take a 0, 1, or more inputs and produce one or more outputs. For the specific case, for the special case, like if it doesn't have any input, we refer it as a source. There are two major sources. One is data file readers. That means you can read your data from some file, like later on we will see that. So the other is to create a basic primitives like a cone, cylinder, or cube by specifying some parameters like height, width, or radius, something like that. We refer those as procedural sources. So you can see the picture here. Sources doesn't have any input, but it produces one or more outputs. But in most cases, you only produce one output. Filter, on the other hand, takes one or more input and produce one or more output. And in VTK, the basic concept is to achieve visualization is you need to connect those modules together to construct a pipeline. And the simplest way to do that is using the method like set input connection and get output port. So you can, for example, connect a source with filter 1. So filter 1, you set input connection. And in the parameter, in the argument, you choose the port from the source. And the similar grammar applied to if the first one is a filter. You set the filter, the input connection for filter 2 as the output of filter 1. So in the rest of the talk, I will omit the data object, just show like this, just connect them together. Okay. When you download VTK from the website, you can see there's some major directories. Although in most cases you don't need to worry about them, but it's good if you know what's the functionality. So most of the core classes are in the common subdirectory, and the filtering directory holds the data processing pipeline operations, and the graphics provides the filters that process 3D data. And the hybrid is combination of different things together. It's more complex. And the imaging is image processing filters, I/O related to data file reading and writing. Parallel here is supporting, the NPI style of parallel. So it's like in graphics term we use the sort last synthesize the images from different rendering process. And finally, rendering subdirectory hosts all the classes that implement different rendering techniques. And widget is a unique feature of VTK. I will explore this later on. Okay, so now let's take a look at our first simple application. Although it's very simple, it has most of the common used components to construct a pipeline. First, take the first line. We first create in this application we are going to create a corn, and it's a manual. It's interactable. That means we can rotate it and zoom in, zoom out, or something like that. So the first step is we create such an object by calling the VTK corn source. So we have a object name like corn. Then we can use the method like set height and set radius to set those parameters. But you don't have to do this. If you don't set the height and radius and the resolution explicitly, they will take their default values. And once we construct a corn source, the next we create a mapper. Mapper is a rendering technique, okay, that is used to rendering the data that out from the source. Then we use set input connection and get output to connect those two together. After that, we create an actor. Actor is an entity in the 3D graphical scene. So you create an actor and you use set mapper to associate the mapper with the actor. After that, you need to create a render. Render is a representation of the whole 3D scene. So it defines something like a camera and the light sources and also a bunch of actors. And you can also define the viewport and the color of the background or something like that. So here you can see I set the previous created actor associated added to the renderer. And then we need to create a render window. A render window is once we create that, we just added the renderer into the rendering window. Finally, we create an interactor and attach it to the render windows. So now we can give it a try. So it's just very short, and let's see what we have. It's like I think it's like less than 20 lines, and I'm going to run this. 1 second. Okay, here is our first application. It looks good. It's a corn with resolution of 10. So it's quite rough. If we have a high resolution, it will be looks more smooth. Next, I'm going to fiddle the application a little bit. For example, I'm going to add another primitive and also control the color, position, orientation, or something like that. Let's see how we do that. So we open the application here. I'm going to zoom it in so you can see the source code. And okay, by the way, I should mention those examples are written in a Python script. So like the first one, the first part is define the source, mapper, and actor for the first form. And I will create the second form the same way. And I created the source, mapper, actor. And after that, I was going to add them to the renderer. So I added them to the renderer. So actor 1 and actor 2. So let's give it a try. Okay, so here is our display of 2 corns with different sizes. And you can see one is fine because I think I give this resolution like 100. Okay, so let's go back. And I'm going to change the color. What I'm going to do is I already have the code ready. So basically, I'm going uncomment the line of these 2 lines. So basically, you see actor 1, I got the property. For that property, I'm going to set the color. So it's RGB. So the first one is 100 is red. The second one is green. So let's see, I save it. And give it one more try. Okay, so now we got it. So we changed the color, quite simple and easy. And now I'm going to change the position. So I'm going to, instead of the default position, I'm going to shift the second form to a center like a shift along X, like a 3.5. And I'm also going to randomly orientate the first form with this direction. Okay, it's X, Y, Z, it's a vector. So you can see the effect. So I save it and run it again. Okay, so this is the 2 corns, different color, different location, and but orientation is different also. Okay. Whenever you need help, you can go to the documentation to see what method you can use. For this class, I just switch to this one. So I go to the Chrome source reference. You can see we have a method like set height, set radius, set resolution. Those are public functions that you can always call to use. Okay, and okay, now let's take a closer look at the VTK architecture. VTK render window is you can touch an interactor with the render window so that you can zoom in, zoom out, and rotate the object in the 3D scene. Each render window you can add one or more renderers. Like I said, one renderer can contain one or more actors, and each associated its own viewport. So that means for a whole rendering window, you can divide it into different portions, and for each portion, you define your own independent viewport, so they don't interrupt each other. So they rendering the content separately. But in most cases, you only need one renderer that occupies the whole rendering window. Okay. And when you want to develop a visualization application using VTK, all you need to do is construct a visualization pipeline, which is composed of one or more sources and optional filters, then mapper, actor, renderer, rendering window, and interactor. Okay, and here is just the diagram shows the example. For each processing unit, it has two timestamps. One recording the last update time, which is when is this unit executed. The second timestamp recording the last modification of the unit. For example, if you for the source, you can see if I set at some time of the point, I set the height or I change the resolution, then it will update change the latest modification time for that module. So VTK adopted a so-called lazy update scheme. It is very efficient. What it does is, whenever there's a request for rendering from the downstream, the update request will go in the direction upstream. So it asks each module to update, but it doesn't. Each module doesn't have to implement. It depends on which one is newer between the update timestamp and the modification step. Also depend on its current update time compared to its neighbor units upstream. So it's the data update flow is from downstream and the request is upstream. Why I say it's the lazy update scheme is most efficient. For example, if you already updated the data from source until to the end, like a rendering window, and then, for example, you change one of the filter, the parameter of the filter, then the source doesn't have to be updated. That means you don't need to read the data from the file again because that the source has been already updated. So it's always check the two timestamps to determine which one need to be updated. So it's very efficient. Okay. And now let's review some of the commonly used classes in VTK. The first one is VTK prompt, and VTK actor, VTK volume, and VTK actor 2D are all the subclasses of VTK prompt. So it defines the entity's position, scaling, and orientation. And the second one is the mapper, and it depends on the type of data you want rendering. You could have a polydata mapper or volume mapper, and so mapper is a rendering technique. And the VTK property controls the appearance of actor, such as color, opacity, and surface optical property like a diffuse reflection coefficient and specular reflection, etc. VTK camera controls where the eye position is and what's the direction you look at, and also the clipping plane that define the viewing frustum. And VTK lights define the light, but those two, VTK camera and VTK lights, you don't have to define them explicitly if you don't feel comfortable to do that, because once you create a renderer, they already created by default. As long as you want to have a better control of the visual effect, you need to define those. VTK renderer, like I said, holds the definition of camera and multiple lights and also multiple actors. Then it's a rendering window, obvious, and the last one is interactor, so that responds to user mouse interactions. So it's quite convenient. Okay, so now let's look at some a little more complicated. I shouldn't say complicated, but look like much powerful visualization examples. So first, let's look at this one. We are going to display 3D machine parts, and the data has been already constructed and saved into a file in the format called STL. It's a stereo lithography format, and I think most CAD software produce such file. So the first part is create a source. So I create a source called part. It's a VTK STL reader, and I set the file name to be the file that I'm going to use. And after that, it's quite pretty much the same way as the previous example. Create a mapper, make connection, and then actor, then renderer and renderer window, and at last I add the actor and control everything, and then finally the interactor. And so basically it's the same thing. Okay, so let me give it a try. VTK Python. Let's go. Okay. So here you can see this is a machine part that constructed with some commercial produced by some commercial software, and I just loaded in using VTK. and I got a lot of polygons here. Okay, so it's very simple. Let's look at another example. I'm going to this one. Yeah. Okay. Large. I think it is. Even larger. Okay, so you can see in this example, I first created a render window, and then I created an interaction. Probably you wonder why in this example, I moved this part to the first place. I will explain soon. All I need in this example is I'm going to import a file from a 3D Studio file to the 3ds. So I use an import. You probably notice it's importer, not a reader. So it's VTK 3ds importer. And I import that one into the window of the render window that I previously created, this one, okay? And I set the file that I'm going to use is this one. Okay, so the rest part is pretty much the same. And the reason that I create the renderer and the render window and the interactor first, because import needs those things. And what's the difference between importer and the reader? Importer, instead of doing more work than reader, because reader just load in the data object. But the importer, in addition to loading graphical the geometrical data, it also loads in the whole scene, the 3D scene, like the camera, the lighting, everything. So so that's the difference. Okay. So the rest part is pretty much the same. So you can see the code is very short, not very long. So let's give it a try. Okay, so here we have a flamingo here, which is constructed and exported from 3D Studio, and now we load the file in, and we can display the beautiful picture here. So it's very pretty. And okay, now up to this point, I should mention that the typical interaction pattern like this: left mouse for rotation, right mouse for zoom in, zoom out, middle mouse for shifting. So it's quite powerful. Okay, so I'm going to show one more example here, which is running VTK. Okay. Okay. So in this example, I'm loading in CT scans, and then from that CT scan, I constructed two isosurfaces, and one is for the skin, the other is for the bone inside. You can see it's a beautiful display, and although the data itself is not so high resolution, but I just use this one because it's very easy to obtain. Okay, so so this is the visualization of this part. Now let's take a look at the code. With some Medi3. All these examples that I showed here you can find them in VTK source code. Okay. Okay, so let's take a quick look here. So the first part I define renderer, render window, rendering interactors. Then I define a source, a reader. I call it V16. It's read the data in. I set the where's the data and etc. And then this, so V16 is a source, and then I need a filter called a contour filter. So that one will extract the isosurface from the volume data we will get from the source. Okay. So the first part is I'm going to construct isosurface for the skin. The skin, the difference is here because the medical data is actually CT data. CT, the computerized tomography. In the image, you see that the bone has the highest density, the soft tissue has relatively lower density, and the air has almost zero density. Okay, so here to extract skin, I set a value like 500. So that one pretty much defines the interface between the skin and the air outside the body. Okay. So I define the contour and take the source as input, as the filter's input, and I also produce the normal of the surface from the volume data. That in that way it will give us smooth looking. Okay, and the rest part is the same. Define the mapper and the actor and everything. And for the bone, we will do pretty much the same thing as we do for the skin, but just the difference here. The value for the to define the isosurface we increase to 1150. Okay, that will separate the bone from the rest of the tissues. Okay, so finally we just okay. Here also we define a outline, a boxing outline. So you see in the demo. Okay. And finally, we add those things, outline, skin, and bone into the renderer, and just boom, and everything is showed up. So it's just so simple, and it's very useful and powerful. Okay. So now let's review some advanced topics. The first thing that I think is worth mentioning is the event handler. VTK provide a mechanism like event observer, and you can define your own callback method, and you can use add observer to monitor any event you are interested in, and associate that with a callback function. So once that event occurred, the callback function is invoked. So in that way, you can respond a lot of predefined events like start and progress and something else. You can also define mouse actions like picking, dragging, selection, etc. Okay. Another advanced topic is I/O. I think that most of the users, when you want to visualize your own data, the first thing you need to concern is the data file type. So probably you produce your own data type. So first you need to look up the data format that VTK support, and to see if your format is one of them. If not, you have to write your own reader. Okay. And VTK also provides a lot of importer and exporters, and you can also take a screenshot in a lot of those image format. You can even make a movie from VTK. Okay. And another advanced topic is widget. Widget is a displayable and also a displayable graphic object that you can interact with other objects. And the usefulness of those things is that you can display those things in the scene with the data graphs you are interested in together to control the aspect of your display. There's a different thing like a point, line, a plane, and a box, and some others. So I'm going to show two examples. One is a VTK plane widget. The other is a box widget. Okay. So let's take a look of those two. The first one is, so let's see which one. Here. Okay. Here we load in irregular volume data that shows the temperature field inside the combustor of a jet engine. Okay. Now you just see the outline. You don't see the internal thing. But we want to create a slice plane that we can map the value, the temperature value on that plane. Okay. So here I can see that I can just create a plane widget which I can manipulate. So I can move the widget, like move it around. You can see the color map on it changed that reflect the different temperatures in the 3D field. Okay, and you can also orientate the plane and zoom in, zoom out. Okay, something like this. Just in this way, you probe the 3D field and you know, to learn your data in a graphical way. Okay, so it's very useful and very powerful. And the second example is a box widget. I'm going to show here. Okay. Here, hold on a second. Okay. Here I show a volume rendering of the same medical imaging I showed before. That you can see I have a box widget here, and I'm going to control the box widget to, let's say, I'm going to narrow down the volume. I don't want to see the whole skull or whole head. I want to see some small portion of it, which that I define like a region of interest. So I can just move around those boxes, and I can move those boxes around, and I can narrow down, and then I can see the region that I really want to look at. Okay, cut it through like this. So now I can see just a portion of the head. Okay, you can focus on anything. You can you can also reveal internal structure in this way. So it's a very useful to use 3D widget. Okay. So another good feature is animation. So VTK provides these two classes for you to use to control animation sequence. And you can use animation queue to define the time stamps, how to control the parameters and everything. And finally is the parallelism of VTK. And you can run VTK on either cluster architecture using MPI-based parallelism, or you can use multi-threading, which is already built into VTK. You don't need to explicitly to invoke them. Most of the filters are already automatically use these features if you run VTK on a computer with multi-cores. Okay. Okay. So if you run it on cluster, you can create the one visualization pipeline on each node and let them run in parallel, and then each will produce either a rendering image with depth map, and then you synthesize them together by using depth map like a sort last technique. So this is another good feature of it. And finally, I just go through those common resources. The original, the official website is vtk.org. You can find the documentation there and the wiki page, and they also have 2 mailing lists. You can register at the user level or at the developer level, depending on what you're going to do. If you want just use VTK, you probably want to just register the VTK users mailing list. And then you can post questions and any difficulty, somebody else on the mailing team may help you. And also, there's a lot of examples that shipped with the VTK source code. And my suggestion for you to start VTK journey is to go through some examples and find one that's close to what you want to display or you want to use, and then alter that one and to fit your need. There are also textbooks and user guide that you can order from VTK website. So that's all. Thank you so much for your attention.